Okay, so let's talk about number 8 from 6.7. It asks us to graph each one of these equations and see where they cross, basically. When you're looking for the solution to a system, you're graphing each one of the equations separately and then looking for their intersection. So let's look at this. Taking the first equation, the 2x minus 3y equals 9, I'm trying to graph that by point plotting. It recommends that you plot 3 points, but on our program it will only allow you to plot 2, and then it draws the line for you. But still, we recommend you find 3 points, and it kind of helps you check your work to make sure they line up. And that's up to you if you want to plot the third kind of on your own paper and just to make sure. But again, the program will only let you plot 2. On the graph given. So I'm going to pick x is 0. That's usually just a nice one to start with, but you can pick any point that you like. 0 is just an easy number to work with. So when I plug in 0 for x, I'll have 2 times 0 minus 3y equals 9. And then 2 times 0 just leaves that out, right? 0. And so we just have this negative 3y equals 9. Divide both sides by negative 3. 9 divided by negative 3 gives us y equals negative 3. All right, so that's 1 point to plot. Now, say I plug in 1. Maybe that's my next thought. 2 times 1 minus 3y equals 9. Oh, this one's not going to work out quite as handy, but nonetheless, it's still a valid point. It just won't be as easy to plot. And I'm sure you've noticed that on some of your other problems. Like you pick a point, but then it comes out as a fraction, which is fine. That is a valid solution, but it just isn't easy to plot. Our program only lets us plot on nice crisp integer points. So, but I might kind of use it as that checking my work thing. You can also plug in on the y side if you like, and I might choose to plug in 0. Kind of looking, I can tell that will cause a fraction too. So, try another nice point. I'm going to try 3. I'm going to skip to 3 and see how that does. 2 times 3 minus 3y equals 9. This would be a more pleasant solution. When I bring the 6 across, and this may happen to you, and you probably noticed it on your other problems, sometimes you kind of have to just keep plotting, keep looking for an easier one to plot. That one comes out, what I would consider nice as an integer, negative 1. Okay, so I've got 2 good points that I can plot on my graph. So, when you're doing it online, you click on the line graph, and it pulls up a line and lets you kind of manipulate it around until you find that point. But here I'm going to demonstrate it just on my scratch paper here. So the point 0, negative 3 would be here, and then this point 3, negative 1 would be over 3 down 1, and then the program just draws connects those points, draws that line. All right, so there's 1. Now I've got to repeat the process. So the second line, 3y minus 2x equals 6. Notice they've kind of got it transposed there, not in the XY order we're used to seeing. If it would have been in order, I might have noticed that these 2 lines are similar. But nonetheless, I would just continue on my process and try to plot some points just like we did before. But what we are going to discover is these 2 lines are more similar than they may look, where this is kind of in the YX order. So let's try to plug in x is 0. That's usually my first thought. I try that anyway, just because it's easier. So when I do so, 2 times 0 is 0, and I get 3y equals 6. Divide by 3, y equals 2. Nice point, plottable point. Maybe I try to plug in 1. So 3y minus, and again, notice I'm plugging in for the x variable, which is over here, kind of where we don't expect it to be, but so it is, and that's okay, but just feel like kind of messing with you there. Move the negative 2 over, becomes plus 2, 3y equals 8. Will a little more than almost 3, 2 2/3. So we can kind of estimate where that is, but it won't plot easily in the program. So let's see. Let me plug in. Can I kind of tell a nice point? Let's see. How about -1, -2? Because you can use negative numbers. You can use any number you feel like. I'm just trying to see if I can save this time. I should have thought of this already, huh? You're thinking. Let's see. -1 would give me 2. No, that's no good. 2 would give me 4. 3. Oh, I like 3. Okay, let's plug in x is 3. I think that's what happened on the other one. I should have remembered that. But in reality, that's not the way I teach it. You just plug in points and see what happens and kind of shop around for that. But I was trying to save this a little time and I wasn't doing very well with it. When I plug in 3 for x, 3y minus 2 times x is 3 equals 6 is 3y minus 6 equals 6. Bring the 6 across. 3y equals 12. Solve that by dividing by 3. There's a nice integer point, 4. Okay, so I've got two nice plottable points, 0, +2, and then over 3, up 4. The program will connect those dots. Now, I didn't do a beautiful job there, but what we should discover, that's not very straight, but on the program be nice gridded paper. These are parallel lines. So the solution is there's no solution. The solution is where they cross. They're not going to cross. So this is considered an inconsistent system. I think the question asks you that. What type of system is it? It's inconsistent. And then if it asks you the solution to an inconsistent is the empty set or no solution. So this was a special case. We might have realized it if we would have solved in the beginning, kind of notice that the x and y have the same ratio, but they have different y-intercepts. So they have the same x-y ratio as what makes the slope of the line that we looked at a little bit in some earlier questions. But you're not responsible for necessarily noticing that. But going through the process, now looking back, I can kind of tell there was something up with these 2's and 3's that were related. And if you wanted to take the time, you could solve this equation for y and look at its slope. Then solve this equation for y and look at its slope. You know, it's x over y value. That's what's in front of the x is its rise over run. And they had exactly the same slope. And that's why they were parallel lines. So no solution. All right, hope that helps.